Okay, let's get right into it. When we talk about AI, you gotta forget the old sci-fi movies, the killer robots, all of that. Because right now, in the real world, AI isn't some far-off concept. It's a tool. It's here. And it's not really about replacing humans. It's about augmenting us. Think of it like human labor 2.0. And this quote, it really gets to the heart of it. We didn't build AI just for the fun of it. We built it because the world we've created, this digital world, it just moves way too fast for our own biological brains. We needed something that could keep up with the scale and the sheer speed of it all. And that brings us to this really crucial concept called human time latency. You know that gap, the delay between you having a thought, making a choice, and then actually doing the thing? Well, AI's entire job, its whole reason for being, is to shrink that gap to basically zero. It's all about one thing: speed. So to really understand just how fast we're talking about, let's look at the physical world for a second. This isn't just about crunching numbers on a screen. This is about real machines moving and reacting faster than any human possibly could. Take a look at this. This is the CASIC T-Flight Maglev train in China. It's one of the most incredible, tangible examples of AI in action you can find. It doesn't have a human pilot. It operates on what the source material calls a mechanical reflex, basically an instinct that's driven by pure data. During testing, this thing hits 623 kilometers per hour. That's almost 400 miles an hour. Now, at that speed, human reflexes aren't just slow, they're a liability. There is no way a human pilot could keep up. And here is where it gets absolutely mind-blowing. Look at this comparison. A trained human pilot has a reaction time of about 250 milliseconds. The T-Flight's AI? Just 7 milliseconds. That's not just a little faster, it's a completely different reality. If there's an error on the track, the AI has already spotted it and corrected for it before a human brain could even process that something was wrong. So, okay, let's step off the physical tracks and into the digital world, because those same principles of speed and automation are totally revolutionizing knowledge work. A great example? SEO. Just check out this workflow. An autonomous AI agent can scan 1,000 websites in 5 seconds. It then creates accounts using techniques to mimic how a real person would do it. Then it writes a unique 2,000-word article customized for each one of those sites, publishes it, and gets the backlink. A task that would have taken a human team a month, yeah, that's now done before you can even finish your coffee. So you'd think this perfect, lightning-fast automation is unstoppable, right? Well, here's the twist. It turns out being flawlessly efficient isn't always the best way to go. The actual data from an experiment showed that these perfect AI bots had a success rate of just over 12%. Almost 65% of their attempts just got ghosted. They were filtered out by other systems precisely because their writing was too clean, too perfect, too synthetic. And the solution here is just brilliant. They programmed the AI for imperfection. They intentionally injected tiny spelling errors, had it use current slang. Basically, they added a little bit of human noise. And what happened? The success rate more than doubled to over 31%. It needed to be less like a machine to succeed. So, okay, we've got this unbelievable speed and this new kind of efficiency. But you knew there had to be a but, right? What's the price we pay for all this progress? And this is a major turning point where we have to look at the hidden costs, both to our planet and to ourselves. This table here tells the whole story. It's from a 30-day experiment comparing a person working alone to a person working with AI. And wow. Yeah, the output, the number of words per hour, it's up over 400%. That's amazing. But look at the other numbers. The energy cost explodes and the human operator's stress levels go through the roof. Let's just focus on that energy cost for a second. A 2,750% increase. That's not a typo. Every single time we ask an AI to turn hours of work into minutes, it has a very real, very measurable impact on our power grid. And to make that even more tangible for you, a single session of just 10 prompts to a big AI model uses, on average, over 400 milliliters of water just for cooling the data centers. That's basically a whole bottle of water for just a handful of questions. And what about the cost to us, to our bodies? This chart shows heart rate variability, or HRV. It's a key sign of stress. Basically, a higher number is good. It means you're relaxed. When working manually, the operator's HRV was at a healthy 64. But when they were managing the high-speed output of the AI, It dropped to 48.2. That's a biological state of high alert. You're not working anymore. You're constantly auditing a machine. So, given this incredible power and these very, very real costs, how are we supposed to thrive in this new age of autonomy? Well, it's going to require a completely new rulebook. This right here is the new vision. It's not about you trying to compete with the AI. It's about collaboration. The big idea is that each of us will eventually have a digital twin, an AI counterpart that handles all the high volume, high speed stuff for us 24/7. And this is the most crucial point of all. Your job is no longer to do the grinding manual work yourself. Your job is to become an expert manager, a high-speed auditor, a quality controller for your AI. The skill isn't the labor anymore, it's the direction and the decision-making. So I'm going to leave you with this final practical thought, a way for you to actually measure your own success in this new world. Ask yourself this: is your AI efficiency in a deficit? And here's the simple test. Measure the time it takes you to fix or edit what an AI produces. If that fix time is more than 30% of the time it would have taken you to just do it yourself from scratch, well, then your process isn't truly efficient yet. It's a simple little piece of math that could completely change the way you work forever.